Ramesh, now that you showed me how to initialize an output pin, can you show me how to actually do the output?
Well, let's try, let's revisit just what we just did. We said we have a microcontroller. We're going to interface pin. We picked port B pin 1. We're going to put an LED on this pin. So we're going to put an LED on this pin, and
there we go.
And there's our
LED. Okay, so
LED.
now I want to output to it.
Okay, so we want to be able to output to this pin. So we want to remember, if you want to output by writing something here, we affect the state of the LED. If we write a 0 here, then the LED is off. If 0 being 0 volts, and if I write a logic 1, that is 3.3 volts, and that should light up the LED. It should be on, right? That's what we want to do. So let's look at how we accomplish this. There is a register, device register specific for output, and for this one has something for port A and B. And this register is described as follows. These are our device registers corresponding to port A and port B, and there are bits associated with each pin. So we are going to be currently interested in working on port B, which means we are looking at this row, and this is the pin we are interested in. This is the bit we are interested in. So what I write here is going to guide what happens to the LED that I'm interfacing. So let's do this. So let's say my first job, what do you want to do with this? Let's say we want to...
I want to turn it on.
Turn it on. So
yeah.
let's turn it on. Turn on. So to turn it on, we're going to write what we are going to do is we're going to write friendly code. And to write friendly code, we will first read the current input. So first step is to read the current input. So read its current state, current state. And then the second step, we're going to affect the desired.
So when you say current state, you mean I'm going to read all of the bits of port B?
Exactly. And then we're going to affect the desired state, and then we're going to write it out. Yeah. So that's the idea. So which means for us, we're going to write our code like this. We have LDR. We're going to get this register address into a general purpose register, and this is called our GPIO BD out 31_0. So we're going to get that, and then we'll read its current state, which is my step A, which is to read it in. So we're going to load it into some register R1, R0. And now that we have the current state, we're going to affect the desired state. We're going to modify R1 first. So first, to do that, the friendly way to do that is we have R1 holding this entire current state. We're going to create another register, let's say R2, which will be our mask register. We'll use this as our mask, and we're only interested in bit 1, so that's bit 1, bit 0. We're going to put a mask here, which is basically all the bits are going to be zeros except for this 1 bit, and that 1 bit is going to be a 1 for us. So I'm going to do a move S R2, and I'm going to put the mask in here, and the mask for us is a 0x02.
Okay, so that has bit 1 set there.
That has, the mask. Yeah, exactly. And now that we have this, we're going to use the OR operation. The OR operation allows us to just modify the 1 bit. We are only going to affect this 1 bit.
So whatever it was before, it doesn't matter. We're going to make it 1.
Exactly. And if these are some XXXXX, we don't want to touch them, but we want to just affect that 1. So we're going to do an OR of R1, R1, R2, And so
All
we
right,
take the
am I
old
done?
value and then we're going to store it.
Oh, we got to store it.
We're going to store it back. So we'll store back R1 to R0, and that's our write back to write it out. So these sequence of steps for us are going to turn on the LED.
Oh, that's cool. But what if I want to turn the LED off?
So if I want to turn it off, right? So we got the same idea. This is the second option. This is to turn off. We follow kind of the same idea again, except now we want to affect this only by clearing it. And so there's a couple of ways to do it, but the proper way and the friendly way to do it is we read the current state, affect the new state, and affect the desired state, and then write it. So here's what we're going to do. Again, we'll load into register R0, R, the GPIO B, D out 31 underscore 0. We're going to read its current state into some register R1.
But how do I clear a bit?
And we're going to do the same thing. We're going to use a mask. Remember, the mask is to tell us what the desired effect is. And the mask is still going to be the same, R2 pound 0x02. But this is where we're going to use an operation, which is a friendly operation called bit clear. So the bit clear, the mask that I provide is saying which of the bits of the register that I want to modify will be modified and the others will be left alone. So I'm going to use a bit clear. So I say bit clear as R1, R1, R2.
Ah, sweet.
And now that I did that, we're done. We're going to store it back and store back R1 to R0.
So I execute the blue code there to turn it on.
Yeah.
And then I would execute the black code if I wanted to turn it off.
turn it off.
Ah,
So
sweet.
this is
Cool.
my off.
Nice.
All right.